Hello, everyone, and welcome to our webinar on the Quantitative Results chapter. Just before we get started with the presentation, I'd like to present this information in case you're interested in additional help outside of this webinar. So we do provide assistance with all aspects of the dissertation. So if you are interested in more one-on-one help outside of this webinar, you can use the information that you see here to contact us and learn more about the types of assistance that we can provide. Just to briefly go over what we're going to cover in the webinar today, this webinar is on the components of the quantitative results chapter. So we will only be covering components of a quantitative results chapter today. We will not be discussing qualitative or mixed methods results chapters. If you're interested in those topics, we do have separate webinars covering the qualitative results chapter. So first, we're going to discuss the purpose of the results chapter and why it's important to the dissertation. And then we'll talk about the different components of the results chapter. So what are the different sections or pieces of information you need in the results chapter? And this will include the introduction, the data collection and preparation, demographics, assumptions testing, the analysis of your research questions, and your summary. And then at the end of the presentation, we'll have an opportunity for you to ask questions. So once we're through with the presentation, you can type your questions into the questions section, and any questions that aren't answered through the course of the presentation, I'll do my best to answer those questions at the end of the presentation. So first, let's talk about the purpose of the results chapter and why it's important to the dissertation. So the purpose of the results chapter is to present the data and the analyses that you have conducted to answer the research questions or hypotheses for your study. So the previous chapters of the dissertation set out to establish why and how you are conducting your study. So your introduction and literature review chapters set up why your study needs to be conducted. Your methodology chapter sets up how you're conducting your study. Once you get to the results chapter, it's time to actually show the results of your study and what you found. So at this point, you will have collected your data and you're doing your data analysis to show your results and the answers to the research questions that you set out in your earlier chapters. And so in the results chapter, you will want to present the findings for each research question and hypothesis with a clear statement that answers each of those. So by the end of the results chapter, you should have a clear answer to each research question or hypothesis. However, you want to save further interpretation for the discussion chapter. So essentially in the results chapter, you are just stating what is the answer to the research question. So if your research question has to do with, is there a relationship between two variables? You are just answering that question, yes or no, is there a relationship or not? And then further interpretation, in terms of, what that result means, why it's important, how it relates to the literature, that all goes in the discussion chapter. And while we will be covering the components and sections that are most typical for results chapters based on our experience with many different schools, you do want to make sure that you follow the specific guidelines or requirements from your school or degree program. So your specific school may have more sections than what we cover. It may have different sections. It may want you to organize the information a little differently than how we present it here. So you do want to make sure that you always follow your school's guidelines. So now let's start to talk about the different components of the chapter. And like most chapters in the dissertation, the results chapter will start with a brief introduction where you restate the purpose of your study, as well as your research questions and hypotheses, and then outline the contents of the results chapter. So when you restate the purpose of your study, this can either be a verbatim restatement of your purpose statement or your problem statement, or it can be an abridged version of your purpose statement. However, when you restate your research questions and hypotheses, those should be stated exactly the same way as they're presented every time they appear throughout your dissertation document. So the wording of your research questions and hypotheses should be the same whenever they appear and should never change. And then after you have reoriented the reader to the purpose of your study and your research questions, you can simply outline the contents of the results chapter by listing out the different section headings that will appear in the results chapter. The first thing that you'll probably want to discuss in the results chapter is the data collection and the preparation of the data for the analysis. So you're going to want to summarize the data collection procedures that you conducted, and importantly, note any changes from your originally proposed procedures. So it's sometimes the case that you might propose a certain method or procedures for data collection in your proposal phase in your methodology chapter. But between your proposal phase and when you actually get to your results chapter, it's possible that those procedures might have changed. So maybe some issue came up and you had to change the way you originally proposed to collect your data. Maybe you had to change the sampling frame or the population that you had to recruit from. Maybe you had to change your recruitment procedures. Maybe you're originally going to recruit through some organization, but that organization was no longer able to help you, so you had to get your data from somewhere else. Whatever the case may be, if there are any changes to your data collection procedures between what you originally proposed and what you actually ended up doing to collect the data, you need to note those changes. But depending on what your school requires, there may be different ways to go about this. So some schools may actually want you to go back to your methodology chapter and change the methodology chapter to reflect what you actually did from what you originally proposed to do. Others will want you to keep your methodology chapter the same, but once you get to your results chapter, they'll want you to explain in the results chapter what the changes were from your originally proposed procedures. So you do want to make sure that you check your specific school's guidelines for how they want you to handle changes to the procedures. And once you've discussed the data collection, you'll want to also discuss the response rate and attrition. So for instance, you'll want to talk about the total number of responses that you received. So if you're doing something like an online survey, how many total people responded to the online survey? And then you'll want to talk about the attrition. So did you have to remove or exclude any responses for any reason? There may be a number of different reasons why you might have to exclude responses. It might be possible that participants didn't meet your inclusion criteria. Like if you had screening questions that they had to answer, you may be possible that you would exclude participants for missing too much data, like they didn't complete the entire survey, so you have to exclude them. Or maybe they just didn't consent to participate. They just got to the consent form and said, no, they didn't want to participate. So whatever the reason may be, you want to state if you had to exclude any participants, why you had to exclude them, and how many people you had to exclude. Once you've explained that process, you'll want to state what your final total sample size was. So after all of the exclusions, how many people were left that you're including in your analysis. And then you may need to do a post hoc power analysis if your target sample size was not met. So this again will vary depending on your school in terms of what they require you to do, but some schools may require you to do a post hoc power analysis if you don't get statistically significant results or if you didn't meet your target sample size that you set out in your methodology chapter. And I won't go into a whole lot of detail about power analysis in this presentation, just because we do have separate webinars that are dedicated to power analysis. So if you're interested in more information on that specific topic, I would encourage you to check out our other webinars specifically about power analysis. And then once you have discussed the response rate and attrition, you'll want to discuss the preliminary data preparation procedures. So this can involve checking the data for accuracy, how you're handling missing data, checking for outliers. It can also involve how you're coding or recoding data or computing scores for your different variables. So checking data for accuracy is especially important if you're doing an in-person or a paper and pencil survey and you have to manually enter in those responses into an electronic format. So if that is the case, then you definitely want to check over your responses to make sure that there weren't any mistakes in the data entry. I also want to talk about how you're handling missing data. So if people are missing responses, how are you going to handle that? Are you just going to exclude all participants who are missing any responses at all and only include participants who had full data? Or are you going to include some participants who were missing data? And if so, how are you going to handle the responses they were missing? Are you going to do something like a mean replacement or an imputation to replace the values they're missing? Or how exactly are you going to handle those missing data? You'll want to be very specific about how you are going to treat those missing responses. And then the coding and recoding of the data can involve a number of different things. So if you're using a survey instrument, for instance, you might have to do some recoding of the responses to that instrument. So for instance, if some of the survey items were negatively worded, you may have to reverse code some items. Or if the instrument has special scoring instructions and require the items to be coded a certain way, you may have to do that coding. And then usually if you're working with survey instruments, there's some kind of score that you compute for each instrument to get the score for the variable that you're actually using for your analysis. And so you'll want to describe that process. So how are the scores computed for each of the variables that you're using? You'll want to discuss all of those procedures as part of your preliminary data preparation. And so now let's just take a look at some examples of how you might write up the data collection portion of the results chapter. So here we just have an excerpt where we state, again, the initial total number of participants that we had, so the total number of survey responses. Then we talk about how we're excluding participants who were missing responses if they were missing a large percentage of the responses. And then we talk about how we're going to handle the remaining participants that we're including who had missing data, saying that we're going to do an imputation on those missing responses. And here's just another example of the same type of thing. with a little bit more detail about the data collection. Again, we say how many participants initially responded to the survey. We explain why participants were excluded for various reasons. And then we state what our final total sample size was. And then here's just an example of an excerpt of how you might write up the results of a post hoc power analysis. So here we state that we're doing a post hoc power analysis to determine the level of statistical power that we had for the analysis. We state what statistical tests we're doing our post hoc power analysis for. So in this case, a t-test and a multiple linear regression. We state what our sample size was for those tests. And then we state the level of power achieved that we got for each of those tests. So once you've gone over the data collection and the preliminary data preparation, you can start to present your descriptive statistics. So you'll usually want to start with basic descriptives before you get into the analysis of your research questions. And this can be descriptives for both demographic information and the variables of interest or the variables that you are analyzing in your research questions. And you can compute things like frequencies and percentages for categorical variables. So that would include things like gender and ethnicity. And then means and standard deviations for continuous variables. So examples of continuous variables might be someone's age in years or their grade point average or GPA. If possible, you may want to compare the demographic characteristics of your sample to characteristics from the population. So if you have demographic information about the population, so for instance, with gender, if you're studying a specific population and you know that the population has a certain percentage of women compared to men, you want to report the proportion of women compared to men in your sample and then compare it to the population proportion to see if your sample is representative of that population proportion or not. And then if you have survey instruments that use multiple items to measure a construct, you may want to present reliability coefficients or convex alpha coefficients for those measures. So here's some examples of how you might present your descriptive statistics. So here we have demographic characteristics that we're presenting for some categorical variables like gender and age groups. And so we have some narrative to describe our table, and our table just presents those frequencies and percentages for each of the categories for each variable. One thing that's important to note is whenever you present a table, you want to make sure that you both reference the table in the text. So you'll see in our text, we say that our characteristics are displayed in table 1. So you want to make sure you have a reference to the table in the text, and you want to make sure that the table appears in proximity to the place in the text where it is referenced. So when you reference a table in the text, that table should appear usually immediately following the paragraph in which it is referenced. So for instance, you don't want to in the text say, the demographic characteristics are displayed in table 1, and then table 1 doesn't appear until 5 or 10 pages later. Similarly, you don't want table 1 to appear before you reference it in the text. So you do want to make sure that you provide appropriate references to your tables in the text. And here's an example of a table of how you might present continuous descriptive statistics for continuous variables. So we see here, we have some continuous variables and we present the minimum and maximum values as well as the mean and the standard deviation. And then here's an example of how you might present reliability coefficients. So here we have a table where we present the number of items in each of our survey scales and then the associated Cronbach's alpha coefficient. So now let's talk about assumptions testing. So after you've gone through your descriptive statistics, it's time to start talking about the analyses that you're conducting to answer your research questions and hypotheses. But each of those analyses will likely have assumptions that need to be tested in order to accurately interpret the results of those analyses. So for each analysis that you're doing, so basically for each research question and hypothesis, you'll want to list and discuss the required assumptions test for that analysis. So for example, if you're doing something like an independent samples t-test to answer a research question, then you need to first list out the assumptions of the independent samples t-test. You'll want to state how you're testing each assumption. So for an independent samples t-test, you might need to test the assumptions of normality and homogeneity of variance. So how are you testing each of those things? Are you testing normality with something like a Shapiro-Wilk test? Or are you using a visual method like a histogram or a QQ plot? Or are you using something else like skewness and kurtosis values? Or are you using a combination of those things? You'll want to state exactly how you are testing each assumption. You'll want to say what the result of that assumptions test was. So again, if you're testing normality, you'll want to make a statement of what the result of that test is. So if it was a Shapiro-Wilk test, was the Shapiro-Wilk test significant or not? If you're using a visual method, you'll want to present your interpretation or assessment of that histogram or QQ plot. You'll want to state whether the assumption was met or not. So again, for normality, you should have a clear statement of, was the assumption of normality met or was the assumption of normality not met? And then if the assumption was not met, you'll want to discuss any action taken to account for the fact that the assumption was not met. So if you failed to meet the assumption of normality, what are you going to do about that? Are you going to transform the variable in some way in order to make the data normally distributed? Or are you going to run an alternative test, like a non-parametric test, to account for the fact that normality was violated? You want to state specifically what course of action you're going to take if any assumptions are violated. And again, it's important to note that the assumptions can be presented in either a dedicated section that precedes the analyses of your research questions, or they can be presented alongside each analysis. And this will depend on your school's specific requirements. So again, check your school's requirements to see how exactly they want you to present the assumption testing. Let's take a look at some examples of how you might present the assumptions tests. So here's an example where we test normality using a normal PP plot. So we're using a visual method to test for normality. So we state that we're testing normality. We state how we're testing normality by inspection of the normal PP plot. We provide an interpretation of that plot saying that the data did not significantly deviate from normal. And then we make a statement saying that the assumption of normality was met. Now, here's an example again of presenting narratively the results of some assumptions testing. And here we have an example where one of our assumptions was violated. So if we see in our highlighted portion here, we checked for outliers and we state that we did have an observation in our data that was considered an outlier. So we need to state how we're going to deal with that outlier. And in this case, we just state that we excluded that outlier from the analysis. After you have presented all your assumptions, it's time to finally present the results of the analyses for your research questions. And you'll want to organize this information by research question. So you can just have subheadings in your results chapter for each research question or hypothesis, and then go through those in order. And you'll want to just go in order of how your research questions and hypotheses are listed throughout the rest of your paper. So if you have 5 research questions, for instance, you just want to go in order of research questions 1 through 5. You don't want to, for instance, start with research question 2 and then jump to research question 4 and then go back to research question 1. You just want to present each research question in order. And similar to your data collection procedures, in your methodology chapter, you will have outlined a data analysis plan or proposed data analysis procedures when you're in the proposal phase of your dissertation. But it's possible that between your proposal phase and after you did your data collection, that the analysis that you had to do has changed. So, whatever the reason may be, maybe you had to change what analysis you had to do. And so if the analysis you end up doing is different from the analysis that you originally proposed, you'll want to note those changes. Again, by either going back to your methodology chapter and updating the methodology chapter to reflect the procedures you actually followed, or by noting the changes in the results chapter. You'll want to clearly identify the variables that you use in each analysis. So for instance, if you're doing something like a t-test or an analysis of variance, then you'll want to identify your independent and dependent variables. If you're doing something like a regression analysis, you'll want to identify your predictor variables and your criterion variable. You'll want to report the appropriate statistics that are associated with each test. So again, if you're doing something like a t-test, you might report the t statistic, the degrees of freedom, the p-value for the test, and so on, as well as maybe a measure of effect size or a confidence interval. And then if your analysis involves any post hoc testing, so for instance, if you're doing an ANOVA with 3 or more groups and it was significant, then you may need to do post hoc testing to determine which groups were different from each other. So if you have an analysis that requires post hoc testing, you'll want to present the results of those post hoc tests. And very importantly, for each analysis, for each research question hypothesis, you will want to include a clear statement that answers that research question or that addresses the hypothesis, whatever the case may be. So if you have your hypotheses stated in null and alternative format, then you may want to include a statement like, the null hypothesis was rejected if you had significant results, or the null hypothesis was not rejected, or you failed to reject the null hypothesis if your results were not significant. So now let's take a look at some examples of how you might write up the results for some various statistical tests. Here we have an example of an independent samples t-test. So we start by stating what analysis we're conducting. We identify our variables, so we state our independent and dependent variables. And then we present the results of our t-test. So we have our t-statistic with our degrees of freedom in parentheses here, our p-value, and then our measure of effect size, Cohen's d. And in this case, the result is not significant because our p-value was greater than 0.05. And so we indicate that our null hypothesis was not rejected. Say there are no differences in the groups. And then we might present some other relevant statistics for the test in a table. So for something like a t-test, you might present the means and standard deviations for each of the groups that you're comparing. Here's another example of an independent samples t-test, but this time we have an example where the test is significant. Again, we start by stating what test we're doing. We identify our independent and dependent variables. We show the results of our test. Again, our t-statistic with degrees of freedom, our p-value, which in this case is less than 0.05, which is significant, and our effect size. So we conclude that there are differences between the groups. And then we can state that our null hypothesis was rejected. Here's an example of how you might write up an analysis of variance, or ANOVA. So again, we state that we're conducting an ANOVA. We state our independent and dependent variables. Then we present the results of our ANOVAs, or our ANOVA, so our F test. And so we present our F statistic, and in parentheses, we actually have two values for degrees of freedom. So anytime you have an F test, there are actually two values for degrees of freedom, which is the degrees of freedom for the effect, or numerator degrees of freedom, which is the first value. And then the degrees of freedom for error, or the denominator degrees of freedom, which is always the second value. And then we also have our p-value, or significance value, for that test. We see here that it's greater than 0.05, so it's not significant. And so we state that our null hypothesis was not rejected. And again, for something like an ANOVA, you might want to present means and standard deviations for each of the groups that you're comparing. Here's another example. This time we're looking at correlations. So again, we have this organized by research question. We actually restate our research question. We say we're conducting Pearson correlations to answer the research question. We state what our variables are in this analysis. And then we present our correlation coefficients. So in our narrative here, we present our Pearson correlation R, as well as the p-value associated with that correlation. And we see that we have significant correlations here because our p-values are less than 0.05. And so we can reject our null hypothesis, which we state here. And then here we just have an excerpt from a table where we might have a table presenting those correlation coefficients. Now here's an example of how you might write up the results of a regression. So if you're doing a regression analysis, you might first start by presenting the results for the overall regression model, which is an F-test. So you present the results of the F-test. So that includes your F statistic with degrees of freedom, our p-value, and our r-squared. So we see our p-value for our regression is less than 0.05, so that regression model is significant. And that r-squared is our percentage of variance explained. So we know that 0.19 or 19% is a significant proportion of variance that we're explaining. We state that our null hypothesis was rejected because our regression model was significant. And then usually if your regression model is significant, you go on to look at the individual predictors in your regression model to see which predictors were significantly associated with your criterion or outcome variable. And usually you would present these in a table. So we have a table here with all of our predictors, which presents the regression coefficients and the significance values. And in our narrative, we have some explanation for which predictors were significant. So in this case, we see that sex was a significant predictor of our outcome. Then once you have presented the results for all of your research questions, so you've answered all of your research questions and hypotheses, you can end your results chapter with a summary. So again, depending on what exactly your school requires you to put in the summary, you can either summarize the entire contents of the chapter or just summarize the findings for each of the research questions. And in your summary, you'll want to restate the answer to each research question hypothesis. So if you have, again, hypotheses in null and alternative format, restate whether each null hypothesis was rejected or not rejected. And then you can provide a transitioning statement to your discussion chapter. And so that brings us to the end of our presentation on the components of the results chapter. Again, if you are interested in additional support outside of this webinar, you can use the information that you see here to contact us to learn more about the one-on-one assistance that we can provide. And so now I will open things up to questions. So if you do have any questions, you can go ahead and type those into the questions section now, and I will do my best to answer your questions. It doesn't look like we have any questions submitted yet, so you can go ahead and just type those questions into the question section now. So one question is, one of your slides had regression imputation. Can you explain what that is? So regression imputation would be a form of missing data replacement. So there are different strategies for replacing values that are missing. So you might have a situation where you did a survey, but a lot of the participants skipped random questions, or they might have just missing data. And instead of just dropping those participants completely, you might want to try to include them in your analysis somehow. But you need a way to deal with those missing responses or the missing values that they have in order to include them in an analysis. And one way people will often deal with missing responses or missing data is to impute that data. And regression imputation is a type of imputation where you'd basically use the information that's available for that participant to try to predict what their answer or their value would have been for the variable that they are missing. And there are Statistical packages will have um, things in there that you can run that will do that process for you automatically. So it's just one type of method for replacing missing values. The regression imputation just generally refers to using the data that are available to predict what the missing values would have been for those participants and imputing the missing values that way. Another question is, can you describe Cronbach's alpha and how this is determined for a survey? So Cronbach's alpha is a measure of inter-item reliability. So you would be interested in inter-item reliability if you had a survey that measures a specific concept or construct with multiple items. So for instance, let's say you have a survey that measures something like self-esteem, but you're probably not measuring self-esteem with a single question or item. It's probably an instrument that's made up of multiple questions. So maybe your instrument has 10 questions that assess self-esteem. What a Cronbach's alpha coefficient will do is compute the reliability of those items and see the extent to which those items appear to be measuring the same concept. So you want your items to essentially be correlated with each other and kind of all go together and measure the same thing. If your items are uncorrelated with each other, then it's a sign that the items may be unreliable. And so the construct that you're trying to measure may not be measured reliably if your items are not very highly correlated with each other. And so the Cronbach's alpha coefficient gives you a way to determine if your survey items are sufficiently correlated or related to each other to form a reliable measure. And most stats software packages will have an option for you to calculate a Cronbach's alpha coefficient by just specifying which items are part of that measure. So you just select your 10 survey items for your self-esteem measure and run your Cronbach's alpha analysis, and it will give you a coefficient. And this coefficient, usually it can vary, between 0 and 1, and you usually want that coefficient to be around 0.7 or higher to be considered sufficiently reliable for most instruments or concepts in the social sciences. So that's just a brief explanation of what Cronbach's alpha is and how you might use it in analysis. And to clarify, so the question is, do you do a Cronbach's alpha on each question or all 10 questions together? You would calculate one Cronbach's alpha coefficient for the set of 10 questions. So if you have 10 questions that are intended to measure one construct or concept like self-esteem, then you'd run your Cronbach's alpha analysis on those 10 items together, and that will give you a coefficient that will essentially tell you to what degree are those 10 items correlated. So if anyone else has any additional questions, feel free to enter those into the question section now. Okay, it doesn't look like we have any additional questions coming in, so I'll go ahead and end our presentation there for today. I'd like to thank everyone for attending our webinar today. Again, if you are interested in more one-on-one support, you can use the information that you see here to contact us, or you can check out our other webinars if you're interested in information on other topics that we offer. And again, thanks everyone for attending today. I hope everyone found this useful, and I hope everyone has a great day.